All right, we're still looking at characteristics of quadratic functions. So we just finished up a couple examples. And the next thing is for you to do a self-assessment. All right, so we graphed in the first video, we graphed a quadratic equation in vertex form, and we graphed one in standard form. So I want you to take a couple minutes, pause the video, and see if you can graph these functions by using the steps that we used in the first video. Also, a parabola passes through the points -1, 4 and 4, 4. Find the axis of symmetry. So if you look at where these points fall on a graph, you know that those are reflection points. And you know that the axis of symmetry cuts a parabola in half. So how could you find the axis of symmetry given 2 points on a parabola? All right, if we have time, I may come back to this at the end. All right, finding a minimum and a maximum, a minimum or a maximum value. Find the minimum value or maximum value of f of x equals 1/2 x squared minus 2x minus 1. Find the domain and range of the function and when the function is increasing and decreasing. Remember, when a is positive, that means the graph turns up and you would have a minimum value. All right, so this function would have a minimum value. All right, so it says for a quadratic function, the y-coordinate of the vertex is the minimum when a is greater than 0. So 1/2 is greater than 0. It will have a maximum if it's negative or less than 0. All right, so these properties can be used to describe other properties of the function as shown. So you can see if the graph is going down, that's considered decreasing. It hits the minimum point and then it starts increasing again. This one is increasing because it's going up from left to right. It has a maximum value and then it's decreasing on the other side. You can also find the minimum or maximum by finding the vertex. We did that in graphing a little while ago. And you can state each one of those similar to what you have here. All right, let's get started with example 3. All right, so we know first that a is 1/2. We know that b is -2. And we know that c is -1. Remember, a is our quadratic term, b is our linear term, and c is our constant term. All right, so if it's not in standard form, make sure you put it in standard form first so that you identify A, B, and C correctly. Once you do that, now we can find the vertex. Again, remember, x equals -b over 2a. So -b in this case is -2 over 2 times 1/2. So 2 negatives make a positive, so we've got 2 over. Half of 2 is 1, so that's just 2. All right, once we find our x value of 2, we can plug it back in to find the y value. So we've got 1/2 times x squared. X is 2. And then minus 2 times x. Again, x is 2, and subtract 1. All right, order of operations tells me to square this term first before I multiply. So I'm going to have 1/2 times 2 squared. 2 squared is 4. Minus 2 times 2, so that's -4 minus 1. Half of 4 is 2. Minus 5, 2 minus 5 is -3. So I know that the y value of the vertex is -3. So we can say the vertex is 2, -3. So we know the axis of symmetry goes through the x of the vertex. So x equals 2 is your axis of symmetry. All right, find the domain and range. All right, the domain is all of your x values. So it's a parabola and it has arrows on it going left and right continuously. So that means it's going to be all real numbers. We can state that by saying negative infinity to infinity. The range is going to be everything above or below the vertex. Since this one is positive, it means it turns up. So it's going to be all y values greater than the y, which is this case -3. So it's going to be all y's greater than or equal to -3. And we can determine that from the vertex. All right. We also can determine whether it has a minimum or a maximum. We already said that it has a minimum because a is positive. So it has a minimum value at -3. And again, that helped us determine what our range was as well. All right, the only thing left, it says find the domain range and when the function is increasing or decreasing. All right, so we can kind of use the vertex to separate when it's decreasing or increasing. We know it's going to be decreasing until it reaches the vertex, and then it's going to be increasing past the vertex. So we can say the function is decreasing. Running out of room here. Let's see. All right, so the function is decreasing when x is less than 2. So you can see the vertex here, x is 2. So when it's less than 2, it's decreasing. That means it's going to be increasing when x is greater than 2. Now what happens when x equals 2? Well, that's the vertex. That's the turning point. You can see that's either the minimum or the maximum of the function. All right, so looking at a lot of key characteristics to a graph, you can figure out a lot of things, a lot of characteristics just by evaluating the function and looking at the vertex and the axis of symmetry. That will help you figure out the domain, the range, the maximum, the minimum, or whether it's in and where it's increasing and decreasing on the graph. It would be good to graph this and then you can visually see all of these things and hopefully they make sense. Example 4, so graphing a quadratic function in intercept form. Remember, intercept form is this form right here. F of x equals a times x minus p and x minus q. These are your two x-intercepts. You can see here p of 0 and q of 0 fall on the x-axis. All right, so that means f of p equals 0 and f of q equals 0. So what we can do, we want to graph this function and we want to label the x-intercepts, the vertex, and the axis of symmetry. First, let's look at the x-intercepts. Those are going to come from these two factors set equal to 0. So we're going to have x plus 3 equals 0 and x minus 1 equals 0. So we're going to subtract 3. So you can see the 0 is actually the opposite sign from the factor. All right, so our two x-intercepts are going to be at -3. So 1, 2, 3, and x equals 1. So we can go ahead and put those on the graph. All right, so we can say, I'm not going to label those on here because I think it'll just put too much stuff on the graph. But you know that these 2 points come from these two factors here. We set those two factors equal to 0, and that gave us our x-intercepts. All right, now we need to find the vertex. We know the vertex is going to fall halfway between these 2 points. So we can count 1, 2, 3, 4. There's 4 units between here. All right, so we know it's going to be halfway between. So our vertex is going to fall somewhere along this dotted line here. All right, so we can tell that x is -1 is going to be our vertex. But mathematically, how would you figure that out? All right, so mathematically, you see that you take P plus Q and divide that by 2. So let's do that. So P plus Q divided by 2. So it's going to be negative 2 divided by 2 is negative 1. All right, so you can see that this is on x equals negative 1. That's going to be the x value of my vertex. So how do I find the y value? How do I know how far down it goes? Well, I can just plug in negative 1. So I'm going to say f of x equals negative 2. And I'm going to use negative 1 for my x. Negative 1 plus 3. And negative 1 minus 1. All right, so I need to simplify. So I've got negative 2. Negative 1 plus 3 is 2. Negative 1 minus 1 is negative 2. So I'm going to have negative 4 times negative 2 or positive 8. So negative 1, 8 would be my vertex. Now, that means my parabola is going to be upside down. Does that make sense with my a value? My a is negative. So yes, it's going to have a maximum value, and that value will be upside down. So we're going to go negative 1, up 8, and that's going to be my next point. So let's graph that. And that's how you would graph a function given vertex form. All right, we have a little bit of time left, so I want to back up and review the self-assessment that hopefully you have already done. All right, so looking at the equation, you can determine that part A, the vertex is 2, 5. Remember, it's x minus h, so the negative sign is part of the equation. So hk 2, 5 is your vertex. Graph that point. And then pick a point to the left or right of the vertex. I chose 1, so let x be 1. Plug it in. You get 7. So 1, 7 is another point on the graph. And then you can use the axis of symmetry to reflect it to get that third point and sketch the graph. So graph, label your vertex and axis of symmetry. The vertex is 2, 5. The axis of symmetry is x equals 2. So x equals 2 is your axis of symmetry. All right, on B part, this one's in standard form, so you have to identify your A, B, and C. Find the vertex by doing negative b over 2a. So your x value is negative 1. Plug that into the function and get negative 2. So negative 1, negative 2 is your vertex. The axis of symmetry would be x equals negative 1. And then choose another point. So I said let x equal 0. That's an easy point to plug in. 0 gives you an output of negative 1. So 0, negative 1 is on the graph as well. Reflected over, that gives you 3 points, and you can sketch the graph. All right, a parabola passes through the points negative 1, 4 and 4, 4. Since these have the same y value, you know these points are reflections across the axis of symmetry. So negative 1 plus 4 divided by 2, basically you're finding the average between these points here, between the x values. Remember, x is your horizontal movement. So I'm finding the average between these 2 points, and that's 3 halves. 3 halves is the same as 1 1/2.